Now this is a story all about how my life got flipped, turned upside down. And I'd like to take a minute, just sit right there. I'll tell you how I became the prince of a town called Bel Air.
Okay, so when dealing with the magnitude and direction problem, it's usually easiest to graph it out first so you can see what you're looking at. So here we have -3, 4. All right. And we're going to solve for magnitude first, which is part of the direction formula. So we're doing the square root of -3 squared plus 4 squared, which equals the square root of 25, which is 5. And then we're now moving on to direction. And for direction, it's going to be the arctangent. So tangent would be from theta, it would be 4/3. So arctangent is going to be, that's going to come out to about 53 degrees. All right, so that's technically in quadrant like 1 for 53 degrees. So then this is also going to be 53, but if we're solving for the whole, it's going to be 180 minus 53. He is pushing a cart that weighs 100 pounds up a ramp 8 feet long with an incline of 25 degrees. Find the work done by gravity as the cart moves the length of the ramp. Alright, the first step is always to draw out the picture. This helps you visualize it and see what you're doing. So we have our picture with 100 pounds of pressure and then 25 degrees with our 8 feet ramp. So the work formula is work equals force times distance. Force is going to be the weight by gravity and distance is the distance the object is traveling. So the first step is going to be to do the cosine of 25 degrees, which equals x over 8, adjacent over hypotenuse. And after solving that, you can get about 7.25 feet, which can go right here. And then you're going to move on to the sine 25, which is opposite over hypotenuse, so y over 8. After solving that, you're going to get about 3.38. And then for the distance, distance equals 7.25i plus 3.38j. All right, and then we're moving on to the work. So we have 0i minus 100j, just seen right here on the graph with 100 force. And then it is not the dot product, but multiplying times 7.25i plus 3.38j. By multiplying those out, you get 0 minus 338 or negative 338. It's negative because when an object is lifted or raised, that's the sign. And then that is the work done by gravity. So that's it.
In West Philadelphia, born and raised.
Product of two vectors in 3D space. And as you remember from matrices, this is the formula, and these lines mean that we're going to find the determinant. So here's an example of two vectors in component form with the components 0, 3, 1, and 1, 2, and 4. So we're just going to set it up in this equation with A1 going here, A2 going here, and etc. And then, like when we find the determinant, we're going to put the first two lines outside the bars, and then take the forwards diagonals minus the backwards diagonals. So these right here are the forwards diagonals, and these right here are the backward diagonals, and we're going to multiply the components of each one, add them all together for the forwards and the backwards, and then we're going to simplify. So for how we got this term right here is the forward diagonal. The vector of I times 3 times 4, and you can see that's right there, plus another forward diagonal, j times 1 times 1, and then the last forward diagonal, k times 0 times 2. And we're doing the same exact things with the backwards diagonals. We have j times 0 times 4 right here, and then the other two the same way. And then we're just going to simplify that. So vector of I times 3 times 4 is equal to 12i plus j plus 0k, and then all of that minus the backwards diagonals here. And that would give you 2i, 0j, and 3k. And we're just going to simplify that further down by subtracting. So 12 minus 2 is 10i. 1 minus 0 is 1j, and then we have the 0 minus the 3, which gives us the negative 3 vector k. And then finally, we have to turn this back into component form. So we just take the coefficients of every vector, and then we just put them into the formula.
So to check your work for the cross product, you can always do the dot product. And the dot product gives you a number while the cross product gives you component form. So you could do a vector times b vector, and then that equals a sub 1, b sub 1 plus a sub 2, b sub 2. And that's just in 2D space. But if you want to do 3D space, you do plus a sub 3 and b sub 3. So you take your component form, which is 10, 1, and negative 3, and you multiply it by 0, 3, and 1. So you distribute the first terms, the second terms, and the third terms. So you do 10 times 0, which is 0. Then you do 1 times 3, which is 3. Then negative 3 times 1 is negative 3. And you add them all together, and you get 0. And when you get 0, that shows that, that the vectors are perpendicular.
Is applying a force of 25 pounds along the positive z-axis to the gear shift of her car. If the center of the connection of the gear shift is at the origin, the force is applied at the point 0.75, 0, 0.27. Find the torque. Okay, so first of all, our torque equation is torque equals AB in the cross product of F. So this is a magnitude force. So what we have to do is we have to use these coordinates and subtract the origin. So since the origin is 0, 0, 0, we can have the same coordinates here as our combined vector. So then once we have that, we have to find the force vector. Now the force vector is the straight 25 pounds of force going in the z direction. So since that is z is right here, that means that it's 0, 0, 25. And now all we have to do is find the cross product of this, where we set it up all here, and you multiply it out across, add the other to it here, across, and then you come to get 0i minus 18.75j plus 0k. And then, to find the magnitude, you do what we've done every time before. You take the square root of all the numbers together, and it comes out to 18.75 foot-pounds.
So today we're going to talk about parametric equations, and these equations help to represent the position of an object, such as a ball, relative to the starting point in terms of time. So there's two parametric equations that are helpful, and the first one is about horizontal distance, and the second is about vertical displacement. So we can find horizontal distance by taking the time and multiplying it by the horizontal velocity. And you have to remember that the horizontal velocity is in terms of feet per second. So if your problem gives you a speed that is, for example, in miles per hour, you have to make sure to convert it to feet per second. So the second equation for vertical displacement is found by taking the displacement due to the initial velocity and subtracting it by the displacement due to gravity. And if we're in terms of feet per second, g is going to equal to 32 always. And then there's another factor, the h. So if some person kicks the ball from, let's say, above ground, so like at 3 feet up in the air, then we make sure that we put that in at h. So we're going to do a practice problem, and this one is, suppose Carly throws a ball at an angle of 5.2 degrees with the horizontal at a speed of 67 miles per hour. The distance from the mound to home plate is 43 feet. If she releases 2.7 feet above the ground, how far above the ground is the ball when it crosses home? So we're going to just write down our two parametric equations to make sure we have those down, and then we're going to solve for the horizontal distance and solve for t. So first off, we know that the horizontal velocity is 67 miles per hour, but we need to convert it into feet per second. So when we do that, we get 98.3 feet per second, and then we're going to multiply that by cosine times the angle, and we know the angle is 5.2, so 5.2 degrees. And now we're going to solve for t. So we know that the height we're trying to find at is when the ball crosses home plate, and we know the distance from the mound to home plate is 43 feet. So we can say that the horizontal distance is 43, and then make that equal to
t times the 9.83 that we found times cosine 5.2. So then when we solve for t using a graphing calculator, we get t is equal to about 0.439 seconds. So now we're going to plug this information into our other parametric equation to find the vertical displacement. So we know that t is 0.439, because we already solved for that, and then times the 98.3, which we found here, and then times sine of the angle, which is 5.2, minus 1/2 times the gravity, which is always 32, times the time again squared, and then the height factor that we have because she releases it 2.7 feet above the ground. And then when we solve for that with a graphing calculator, we get 3.522.
Started making trouble in my neighborhood. I got in one little fight and my mom got scared and said, "You're moving with your auntie and uncle in Bel Air."